Okay. So I think we got three more to look at from 14.1. Number 32, it says use vertices to describe two paths that start at vertex I. Vertex I. Just going to draw it. Just going to highlight it. And ends at vertex D. Okay, so I'm just kind of highlighting the two that I care about. There's a couple of things I could do. I could list out each potential path to D. I think what I'm going to do is I'm going to look at each option, and I'm going to see if each option is a viable candidate. For instance, if I start with option A, it says go from I to H to G to I to D. Okay, that doesn't make sense because I can't jump from I to D. They're not connected. All right, so that's no good. Part B, I, G, F, E. Now here's E by himself to D. Well, there's no way to connect that. All right, so let's keep going. I, G, F, D. Well, we could stop there, really, but it keeps going. B, back to D. I'm not allowed to backtrack on myself, so that's no good. Part option D, I, G, yep. Option D, I, G, H, D. That doesn't make sense. You can't skip over. And then looks like I'm running out of options. I, G, F, D. All right, that one's good. Let's see about F. It does say 2, so I'm guessing that one's got to be it. I, H, G, F, D. Okay, those are our 2. All right. And then the last 2 I want to do are on the same page. Number 37. It says to choose a graph with 4 odd vertices. An odd vertices means that there has three lines or 3 edges. 1, 2, 3. Another possibility is if there was a loop. So this loop B has 3, is odd. Okay, so we're looking for 3 of the vertices to be odd and at least 1 loop. Okay, well, at least 1 loop. Let's start there. That means that this is no good and that's no good because those don't have loops. Throw those away. Now, part B does have a loop, has 4 loops, but do the loops have even or odd degrees? 1, 2, 3, 4. So A has degree 4, and in fact, each of these have the same. So these are even degrees. So it's not B. So it's either D or E. So let's see what happens with D. There has to be at least 1 loop. Check. Next, there has to be 4 odd vertices. All right. So A has 1, 2, 3. B has 1, 2, 3. That's good. All right. C and D both have to have odd vertices. 1, 2, 3. And then D, 1, 2, 3. All right. So it looks like our answer is D. And then lastly, You may find this one easy. I thought it was a little tricky. So we're going to do 38. It says find the graph with 5 vertices and exactly 3 bridges. Well, I think they all have 5 vertices. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 5. All right. So what I'm interested in is which ones have the 3, exactly 3 bridges. Okay. So I'm going to start with C. What I'm going to do is process of elimination. If I remove CE, I'm starting with C because this is kind of all the same. Like this CE, if I remove it, the same thing happens there. So if I remove CE, that's a bridge. But the same thing here, here, and here. So that's actually 4 bridges. So it can't be C. So I'm going to throw that away. B, well, this is not a bridge because if I remove that, I can still get to E. If I remove that, CB, I can still get from C to B. Boom, boom. If I remove BE, I can still get to those. So I argue B doesn't have any bridges. Okay. So I'm going to throw B away. I'm assuming by process of elimination it has to be A since one of them is true. But let's check because what if you had other options? This is a bridge. A to C is a bridge. And D to C is a bridge. And then C to E is a bridge. So that's 3 bridges. Let's see what happens here. If I remove BE, it's actually not a bridge because I still have this little piece that goes back. And same here. So that stuff is not a bridge, just 1, 2, 3. So it looks like A. All right, so we're going to stop 14.1 there. If there are other questions, just let me know. We can talk more about some of the others, but those were the ones I thought were the hardest